Hello and welcome back to Advent of Code. My mouse is just not going. So picking up where we left off, we finished part one of day 22. So I thought we'd have a bit of a look at part two. I've had a quick look at it outside, and I've even put in some like boilerplate. I think. I have not pushed it, but what I could do is just quickly go to this one and do see, day 22, part 2, boilerplate, and push that up, I guess. And that pushing? Yeah, cool. And if we go back here, we can probably pull that again. And yeah, now it's got day 22, and Hexia will probably crash because it's like, whoa, you have changed a file. It seems alright. So what happens now if we do 22 and say example is it should panic at the end. So it basically saying unimplemented, and it prints a little thing. And if we say build is day 22, it even shows a little graph on where it goes for the part 2. So part 1 it's still good, and in the diff it shouldn't show. Oh no, that's all good. So how the problem is, the first part of the problem was we basically had this map and a set of instructions on how to traverse the map, and when you went off the side you would wrap around. So say if you went off here you would end up on this side, and if you went up here you would end up down here. And you can kind of see that with the example path. You go down, and when you get here you oh, that's right. This map is a bit iffy. So if we look at this, yeah, we go down and then we go off to the right here, and wrap around and then go down, and go down here, but then wrap around to there. So the part 2 is basically saying, instead of that input, instead of treating that input as a 2D plane, it's actually a cube. And so what I've actually done is made up a little bit of paper from a back of an envelope, and you can kind of fold this up. It's not like to scale, but you can kind of make a cube, and each side has some numbers on it, roughly corresponding to these, which I guess are the regions read in order that they're read. So this is the first region, second region, third region, fourth, fifth, sixth, like that. And when they fold up, they kind of fold in a way that, say, so this A is really going to 6, so that is because 4 and 6 kind of go side by side. So there's 4 and there's 6 there. And what that means is you basically have to work out, when you're going off the edge, you need to work out which other face you're going in, and also which direction you'll be facing. Because in this, if you go off that way, you're actually going to end up going down that way. And here, when we say C and move down, so that is 5. So we on 5 and 5, and if we move down, we should get to 2, but it's like an upside down 2. So that's this here, saying that if we go down from there, we actually go up from there because the 2 was upside down. So, and then you basically follow the same rules, and you just have weird jumping. So from here we actually go to here, and then we go there, and then from here we go to here. Interestingly, it's the same examples they kind of mention, but then here when we go up, we stop there. So it's reasonably close to the first one, but in the answer, the final password is worked out the same way, depending on where you are on this 2D map. So there's a couple of ways around this. What I could do is maybe we'll get back into our Serenity, and if I open up our input, we can see how that is. And one thing to note is this is a different shape to this. So here we've got like one little thing at the top, whereas here we have like this is like starting from there going up. That's like one block there and one block to this side. So we got 2 blocks, then 1 block, then 2 blocks down the bottom, and then another block there. And these blocks are bigger, but in theory they should be like still being able to work out. So here's the actual input I have for mine, made up a different little cube. This one was done slightly more to scale, well, more accurate cutting. So we have a little cube like that. Interestingly, my friend that also did this, he had a different input in terms of where the walls are, but the same shape. And he decided that instead of kind of working out how to algorithmically fold a piece of paper into a cube to work out which facings everything is, he decided just to hard code just the actual input. So his doesn't work for the example input at all, I believe. Whereas I kind of want to have a stab at how to do that. I'll just move that up because I think I don't actually have a picture of what the camera looks like when I'm recording, and in fact I don't even have, there's a little window there, but it was hidden because I've got everything full screen. So what I want to do, so I was thinking when I did this boilerplate of not really changing too much on how it goes, and really just say when we try and go off we do something different if we're a cube. And so how I went about that is I basically say it's a cube and then just do all the instructions again, reset it to where we are. We start in the same place, same orientation, and then if we are a cube in wrap, it will basically panic saying we haven't implemented that. So here lies the tricky part on, well, first off we need to know how big the cube is, and I've kind of hard coded it, which I would like to kind of have another function on a grid that we can fold it, so we basically do this process one at a time. So we'll get one and we'll fold it over, and then we know that 4 is like a neighbor of 1, so 1 is on the bottom. Imagine like 1 is on the bottom now and 4 is and like the top is pointing to the screen there, and so 4 is kind of at the bottom end, so we could probably call it the south neighbor, and then the orientation of it is the same, so it just goes 1, 4, and then when we fold it's kind of the same. And we can kind of store it like that. So what I'm imagining is another structure, struct cube, and maybe it will actually just extend grid. I might try this. And what we can do then is kind of override this wrap function, but the next will still kind of work the same, and the first all the same, and the toString all the same, and the pass I guess not. But in the cube we kind of have and yeah, I guess we can't actually have a structure because I kind of want to well, actually, yeah, I'll do it this way. I kind of want a thing like this, except I don't. Well, I'll see if this compiles. It probably won't. It does not, because we can't do extend. What if we do it as a class? Right, that for. So you can't extend structures. Kind of makes sense because I've made it recursive. That a cube reference itself. It kind of means that the what am I thinking? Because it's recursive, it can't be a struct because that's copy by value. So like everything's on the stack rather than in the heap. Whereas when we have a class, we can have an actual reference rather than a copy by value. Otherwise, it just won't work on a struct. And I've run into that a few times. So this still doesn't really work, but that's alright. I'm unsure what it's complaining of there, potentially because it's expanding that. And this isn't really we can either have a cube like this, but this isn't really a cube. This is really a cube face. And so in this example, 1 is a cube face, and its south neighbor is 4. And when we fold up 4, 4 then has a west neighbor of 3, but because 4 has a north neighbor of 1, you can kind of say that 1 has a west neighbor of 3, but the orientation has rotated. So here 1 is pointing upwards, and then there 3 is like on the side. So we also need to kind of have a orientation, I guess. And what we have, we kind of have like an instruction type thing. So we could do a rotate. And potentially I could add to this, yeah. But yeah, we kind of want maybe we can just have it as a string and a cube face, like so. And so that string is basically going to be a series of R and L's to either rotate it clockwise or rotate it anti-clockwise, or just spin it around twice. We could also go out loud. Or we could also just have an empty string, which means it's the same orientation. So that's one way of having a cube. The other way I was thinking was we could just have a set of cube face, and that's just like an array of cube faces, and in that we can kind of have an order. So one is at the top, I guess, and when you kind of fold it up, it does things. For the folding function, I kind of like this structure a bit better, and yeah, so we also have to have like a mapping from a face back to the grid, I guess. And so here we could probably have a position, and it can be like the corner. Corner can be position. It comes with a direction, but I guess we don't care about that. And here the the like position we are at, like we need to know that, in fact I think it will be easier on this one. We need to know that when we're on this face here, where the top corner is, and when we're on this face, where the top corner, and here where the top corner, and here where the top corner. And we potentially care about the direction, and we could probably use that direction on like how it's done. Yeah, like how it's done. I don't know, I don't have the words, but yeah, so if we have a function fold that takes this and it returns us a cube, I guess, and maybe the cube is the thing that expands grid, and yeah, that doesn't have that. And we will return just one of these. So we'll need to kind of make all the faces. And we kind of need to find the faces. So to do this, we need to know how big the size is. And how I did it here was basically, if it's only 12 tall, it's 4, and if it's not, then it's 50, which kind of matches with the input description, that it says it has 50 by 50 regions, but the example only has 4 by 4. So I guess we could do a similar thing here in the fold, so we can like have new size, and that can maybe just equal 50, and if dot grid dot size equals 12, then we can set size to be 4 uz. So we have a size. Now we just need to find a face. So the first face is probably going to be in the top row at some point. And it's probably actually just going to be just whatever we get back from first. So first returns a position of basically the first row that's like a thing. Well, actually, it returns the first thing that is a floor, and there is a chance that this is not a floor. In fact, what does it look like in the actual input? it is a flaw, but there is a chance that that is a hash symbol, and the first will actually return the next thing. It will return something though, and what we can do is like mute, make sure it's at the right place. So say we had our first there, we can, the y will be right, but the x should be a multiple of the size. So say in just the example input, we have basically 8, so we will be at index 8, 0 for x. X equals 8, and we kind of want to subtract the we want to subtract first dot x mod by size, which will say if we were actually in the second one, because for some reason there was a wall in that first place, then we would be at 9, 0, and 9 mod 4 will be 1, so if we subtract 1 off 9, we should get 8, so we should get the top corner, and the y should just be the same. So that is the edge of our first thing, and instead of like doing this size here, what we could do is actually no, we couldn't, because if it's a wall then we can't, but I was thinking we could basically go here and then see, can we go like work out this width, and this is too wide, like it's too wide quite literally, but we can take that and then see, can we go 2 down, and if we go that amount down we get to this point here, and if we try again we can't because there's an empty gap here, so that means that the width is probably half of this size, and then it would just work out, and like if for some reason there were 3 there, we could a third the original size and so on. And I guess we could, instead of doing this, we basically step back until it is either out of bounds or out. Anyway, so now that we've got this one face, we could probably create a face out of it. And I think these need to be kind of and I think I also want first dot position equal like up, dot direction, direction equals direction up, like that, and like maybe we can get away with these strings here. So mute, maybe we'll call it a candidate, and this can be maybe it can just be whatever first is, and we can go candidate dot x plus equal size, and here we can test whether dot grid, well, we can test whether candidate dot x is a less, if it's greater than or equal to dot grid candidate dot y dot size. I don't like this name. We are just going to call it C now, I guess. And like maybe that can just be F. So if it is greater than or equal, that kind of means that we want c.x to be f.x and c.y plus equal to c.y. And if that doesn't, yeah, I think if that doesn't catch up with anything, so basically we're going from here and we're testing this thing which doesn't exist, and if that doesn't exist, then this one should exist, because if it doesn't, then it'll just be a single face by itself that can't be folded with anything. So everything has to be attached. So that should be that. And here, I guess if grid c dot y c dot x is out, we kind of just want to do the same thing. Do that. Can't do it in the same thing, and this is kind of assuming that maybe we could probably do it else if like that. Yeah, so if we overflow to the right, then we go down. Otherwise, if we're out, so we have an overflow, but we have like a gap in the map input, then we go down as well. And so at this point, we should have a good candidate. And I guess we need to know where it is. So I guess this is the I think I want to do something like this, and maybe just do that and that. And here we can, what can we do? And if that is the case, then it is east, and in these two cases it is south. Right, so once we have our first, that's our position. So we could probably make a thing here. Mute face equals cube face, and position can be whatever f is at the moment. And I think these need to start off as none. Equals none. Like so, and then we can make a face, and if it is here we can we kind of need to make a new face like that. Yeah, so maybe mute C can be is direction, position is a structure that is important for me to know. So we can make another cube face with that, and it can also just be that, and maybe we can go q c dot position dot x plus equals that, and yeah, I don't really like adding in all of this, but it kind of works. That isn't right, and that also isn't right. We just want to add size. Right, so here we have, maybe this can become first again. And we need that again. Right, and so here in this case we can actually go face, maybe we can just call that one F. So we can go face dot south equals C, and same thing here, and here we can go face dot east equals C. And so that has done the very first fold. Now what we need to do is continue folding, I guess. So I guess sometimes you might have ones like this where you have two neighbours on that first one, so you can have both south and east. And then sometimes you can just have one neighbour. And when you get to other neighbours, say the 4, you can have ones that go to the... that is actually... No, that is it. Yeah, you can get some that go to the east. So this is kind of hard coding to assume that it is that top one, so it can only go to the south or the east. In general, I kind of want a like better function to like take a face candidate and then just fold it as many times as needed, and maybe that will recurse. So what I'm thinking is we have like a helper function which will take this and it will take a position, and that's just a position, and that will return a cube face, I guess. Yeah, and in that a lot of this will just kind of happen. So here we can do that, and we can probably I kind of want to return all of them, but yeah, we can maybe get a let top equals fold of this dot fold, and give it position. We can probably just give it position like that, and maybe we can just call this position. Get that mouse somewhere else. Well, we'll use it to do this and that and this. And here we can probably have a mute, what do we call it? Faces, and it's going to be a type of cube face, and it can just equal that. We can faces dot push top, and we can also do top dot north and bang that, and we're also going, that's not what I wanted, maybe maybe if we copy to there, and that's also kind of not what I wanted, but that's right. And we can add in all of those corners, and then we can also faces.push top dot say north dot north. So I guess north is like not the best one, but basically if we go north from there, we go to there, and then we go to there, which will be the sixth thing. So we should have 6 things here, 1, 2, 3, 4, 5, 6, and that should also need a bang. And then we can return a cube with faces. And cube extended grid. So potentially yeah, I think we need to do something like that, and in this wrap we can probably get rid of that, but this we have a wrap on here, and maybe go back there and go here and just panic unimplemented cube wrap. And yeah, all that stuff won't exist, and the dot cube, I guess, doesn't exist. So what we would do is keep that be let, but we can let cube equals grid grid.fold, and like that could be just cube.first. It'll do the same thing, I guess, and then instead of executing on the grid, we do it on the cube, and that should call like this next, but then it'll call the other cube here. So what I want to do is maybe take this and put it up in this underscore fold. So we have our position, and maybe we can call that ret, and we can just have that, and that is our candidate. This can probably also just come up here. Like so. And I'll probably like comment out all of these just for now, just because they won't exist. I just want to see whether this happens. We'll find out. So probably need that, and grid needs to be dot grid, because it is a grid as well as a cube, I guess. And here that's ret, and this is ret, and this is ret, and this we can have to do more recurse. In fact, potentially we want to pass in. Yeah, I think we want to pass in the mute face, and it is going to be cube face, and it is a class because it's recursive. Yeah, so we won't do any returning and here in fold we will just make that thing like that, and here we can have a cube face of position like that, and then it will call a fold and then add everything into the actual cube, and that way we can kind of recurse on this with a new face like C. But for now we will just do that, and I'll give a little test. Compile doesn't like that. We probably need some throws. Gosh, it's got a lot. Right, so we got here. We can't do that. Corner is what we call it. Maybe I will just call it position, because I use it like that. Maybe let's set up a gutter for myself to scroll back to. This one here doesn't like that. Position doesn't exist. Right, where are we? 95. Position. Yep, so we don't want that there. And this can just be face dot position, and position is that. And that can be that instead of there. Maybe that will do it. Maybe we'll set up a little gutter. Right. We call some private things. Yeah, cube face. We can't get that. Maybe I'll just do that for now. Yeah, I guess this fold could just be on there. Yeah, maybe I'll do it like that, and function fold. It can take this. It can take a mutable this, and it can take a grid like that, and it will just do that and that, and just copy paste that into there, I guess. And maybe that grid dot size if we do it that way, and that's the only way we do size. The ret is just this. And so here we would actually go open mute top dot fold of this like that, and maybe we can go grid is this. Yeah, I think that's kind of what I want. And so face doesn't exist, it's just this now, and grid dot grid needs to be like that. Yeah. Anything else that needs changing? No, that's probably good. We'll do a little gutter and do that. Potentially have more stuff. I don't know. Yeah, it feels like maybe I missed a brace somewhere. Yeah, I might just quickly look for braces. Oh, that just doesn't tell me, but yeah, that goes there, that goes there. yeah, we've got this dangling brace there. Set up a gutter and do that. Yeah, that looked better. It only had like a couple. Right. Cube face needs to throw. So 91. 91 is here. Because we do that, we need to throw. And because we throw there, we need to throw here. And here. Right, so we can't do this because fold is private, but we can make that public. Right, so we can't do this because face is expected grid because we need to have it in that order, right? So we can just go like this and then do faces. It's one thing about Serenity is like you not Serenity, jakt. You have to provide the parameter names as you're doing it, but they also have to be in the right order, which in my opinion, like if you are already passing in the variable names, it should like kind of just not matter. So say we won't be able to do this, but say you had a Python thing and you had like a foo and it had like A, B, C or whatever, and it did something. We can call this and go like B equals that and A equals 5 and C equals and we can kind of do it out of order, I think. I can't like quite recall. I could, yeah, I think I'd have to go into here and then test.py doesn't exist. Gotta check these things, otherwise there might be a thing. So maybe we have A and B, C, maybe we can, yeah, just print. How do we do Python again? Gosh. Yeah, I think we do that, but there is a shorthand for it. I can't recall it. But here we can probably go B equals B, C equals C, and A equals maybe A equals 5, and maybe we can go A equals B equals and C equals in our print. And so like maybe if we Python that, we should get A equals 5, B equals B, and C equals C. So we've passed in the parameters out of order. In fact, I wonder if I can go that. So we had things there, and we say what parameters are, but if we take these kind of assignments out, which you're allowed to do in Python, it'll be in a different order, so it'll be in the order that you pass it in. And I think if you do like just one like that, it will, no, you can't do that. You can only do that if like the last one, yeah, so it defaults A to be the first one if you don't provide it. So there's some stuff there that is kind of cool, but yeah, in jakt you have to have it in the right position. So here, was it the top? Yeah, cool. We can't do that because cube doesn't exist here, but if we go like grid is the cube, it looks like it compiles. So, oh gosh, it doesn't like that. Right, so we try and do a fold. because it's like a class, then it's pointed to it, but it's failing because that. I wonder if we can not have it as a cube, which will fail at this point, and yeah, that will just fail there because it's like not a correct thing. Yeah, so it kind of does need to extend, but then it doesn't like it in C++ land, which is always fun, because you have to kind of work out what it wants you to do in jakt to do it. I like the idea of the transpiling because you don't have to think too hard about how you're representing your language intermediate representation, and then how you like output that to machine code or assembly or something. Whereas if you transpile, like you can, it's kind of cross-platform for free in a way because it is cross-platform as C++ in this case, which I don't know, C++. You can get a compiler for most systems, I believe. But then you run into like issues where C++ has certain paradigms, and then jakt has certain paradigms, and they don't always gel together nicely. And I believe the long-term goal for jakt is to kind of get away from the C++ dependence, but for now I think it does a good job. But you occasionally run into these issues that you're like, I don't want to try this. Right, so basically when we're folding, it's not liking yeah, it's not liking that because it's trying to like unreference it because it's pointed to it, and like we return it there, and we just do it here, but it doesn't like this. I wonder if we can do some funky shit, and like just say it's an optional, and then just return some cube, so it like always returns it, but see what happens. It might fail, it might not. It still does, potentially in the same place. Yeah, so now it's like trying to get that, but yeah, putting it into like this non-null ref pointer, which is a cube, but then cube doesn't know how to unref things. So maybe I will go back to that, and maybe I'll just comment out that line there. And where are we? Yep, we won't just return that and not be optional. So I'm just wondering whether this compiles. So we're not trying to execute it now. So we're literally just doing that. And the other change I want. Apologies. The other change I wanted to do was do that, and we can't do a bunch of stuff because it's not a cube, so we can't do this as well. Because it is... wait, it doesn't know what a cube is? Why does it not know what a cube is? I guess the cubi it now doesn't have a grid, so we can probably get rid of that. And see if that compiles, and if that compiles, then yeah. So I think we have like a kind of thing here. So we have like a class of foo, and it extends a s, say, and we have a struct s that does some things, and we have a function main which will create a foo, let f equals foo, and maybe it will print line okay like that. And maybe we can jakt this. Oh, I wonder if we can do this inside of them. It looks like we can. Right, so here we have that thing. And I think, yeah, so we couldn't do that inside of them. I think if we change the structure to be a class and compile that again, that will work. Yeah, so that kind of works, and if we go build test, it should go okay. Cool. So the issue is that we can't have struct, which makes sense to me, kind of. Because class is by reference and struct is by value. So when you create a new foo, you're creating a reference to this thing, but because it extends this s thing, which is not a class, so it's by value, it doesn't really make sense. And that's why we're kind of getting like this weird error that it's trying to unreference it because it just doesn't exist. Yeah, so foo doesn't exist as like a referenceable thing. So I wonder if, say we go back to this place where it is a grid, but here we say a grid is a class, and that means that we probably need a bunch of publics for our functions. In fact, let's let the compiler tell us where we need stuff. Right, so we don't have first. First is here, we can just go there. It still doesn't know first, because it's probably because of like something. Yeah, we can't even pass it, so it doesn't even know what things are. So we do that, we do that, we do that, we do that. Basically, all of them should be public except maybe that underscore wrap, which potentially I'll just make it that. Yeah, so we can't do that, but we can just make that public. What would be cool is if we could have a protected, which is a thing in Java, which basically means if you're extending this class, you can access this, but if you're outside of the class, so if you had a class foo of grid, you could have a function here that maybe just returns stuff from grid. Whereas if you had a completely different thing that passed in, say, a grid of grid, we couldn't go like that. But as far as I know, jakt doesn't have that, but it's got a public, so we'll just do public for that, and like it's Athena code, so who really cares? So 3 func, and we'll just get rid of that 3. And right, so now we've compiled that with classes for both. It should go. Yeah, cool. It goes, but we also have some stuff down here that is commented out. So now I'm hoping that it will panic. because it tries to call that other wrap function. And anticipation, I'm hopeful. It doesn't. It gives an answer, and it just gives the same answer. So I guess, yeah, I guess. Like this wrap is not getting called from here. And we can potentially recreate that in our test.jakt file. So we have two classes, and here we can have a function foo, and it just returns a print lines. Okay. And on S we have a function foo, and it can print line bad, and here we can also have a function bar, and this should probably take this as well, like so, and the bar, that can just do .foo, and so here if we do that and we go f.bar, and if we compile that, right, so we can't do that because of public private stuff. Really just this one needs to be public. So if we compile this, I would expect it to say bad, just because of what I've seen in the other thing. So if we build test, we get bad. Now what's interesting is, say if we add public there, say if we also call foo on that same object, I now expect it to say bad, then okay. What I would want to say is okay and okay, but that's not the case. So I'd say, I would actually say this is probably a bug with inheritance, that we aren't calling the correct function of overridden class, which puts a spanner in my works, I guess, because yeah, I'll have to kind of rethink on how I will like say it's that. So I wonder if we could do something like this as bang foo, and see if this lets us do it. It might not. It does. It does for now, but well, actually no, that didn't like it. Right, so it is based off. Like, I get it. It's trying to say that an S isn't always a foo. Can we maybe let foo equals this thing, and here we can, if foo dot has a value, we can go foo bang dot foo, otherwise we just go dot foo, like that. And if we do that, compile errors, I love them. Right, so we didn't even get there. target must be a reference or pointer type to a defined class. So maybe this needs to be like down here. You never know, but no, I don't like that. Yeah, so I am like kind of unsure how we might go about this, but what we could do is actually pass in a foo like that. Yeah, and maybe we can go back into this. I'm just trying to work out how I can get about it, and here we can probably go foo is F. Yeah, see if that it looks gross, but I think it will work. And now hopefully it says okay. Build test. Okay. So here we can probably get rid of that. We can probably find the publics and get rid of those ones. And here we just have this like gross thing. Like it's basically, yeah. It is gross, and I guess we don't actually need that, and we can just pass that, and we can do. We can't do foo bang.foo. Yeah, so we would still need this one to be public. Yeah. So that should say okay, and I think for the test case I'll also have one that just doesn't have anything. So we'll have okay then bad. And I think I'll probably stop this video and work out how to fix the compiler for this. I suppose I can work around it by doing that. Yeah, so what we would need is this, and fuck me, this is public YouTube bug. We're not in Vim anymore. Get too used to using Vim and you do some things. And so here in maybe this next. No, where do we do the next? We do the next in this. It's real gross. What I think I might do is. I could have it reference it now. That could lead to some errors. I think I need to pass in the cube there. Yeah, so in this we get an instruction, and in here we maybe can have cube bool. Maybe we can just have cube, and it is none by default. And here we can pass in the cube in our next thing. And if we're rotating, we don't need to do anything. Yeah, and then in the next function, we would also pass in a cube, which is a cube, and it defaults to none. And here maybe we can just pass it to this wrapped function, and in the wrapped function we go cube defaults to none, and here I think cube dot has value that, then we just want to return cube bang dot underscore wrap of position like that, which will then call this function, which should go unimplemented. So let's see if this goes. Where do we have our test? That one. Looks like it's compiling, which is always good. And it's still got a answer. Yeah, because we never actually. Maybe we could do something like that, and well, actually no, we can just go grid is grid, but grid is cube, but we also pass in the cube. It looks gross, but that's alright, and potentially have to reorder this, so we can probably just do not that, maybe on the side of there, if we do that, yeah, so that looks good, and it should panic saying that we don't know much, and like I feel like I haven't really achieved that much. I gotta panic. Like I haven't really done this folding thing yet. So like at this point, if we take these away, it should fail here because we haven't made a full cube, I guess. Right, we can't get all of that stuff because these are just, gosh, public. Didn't really want to do that. Actually, no, what we could do is build a cube just from this. Public. Yeah. Maybe this thing will return us the cube. And we can just return that, and this is kind of what it will do in after the fact. And this will just be nothing. This. And yeah, that's probably what we want. Right, we just want grid like that. Grid dot grid. Grid. Cool, that looks good. And now it should fail on that constructing of the cube because we don't actually construct the cube. Yeah, so now we have assertion of has value. So I think what I want to do is here have a if 1 equals 1 panic implement, maybe just to do cube face fold recurse, and do that, and I think I'll leave it there because yeah, I got quite stuck on compiler errors, always good, but yeah, now it should yeah, to do cube face fold recurse, and it should still be getting the part 1, which, gosh, is that the right answer? Part 1 was 6032. Yep, looks good. So yeah, I think that's good, and in the next episode, I guess, I'll go through and actually fully fold this thing. Now that we've got all the boilerplates set up, that it will actually go to this, and once we do this, we'll then need to do some more logic on what happens when you step off the thing. So there's 2 things to do. There's one building the cube, and then one traversing the cube. But I think the way I've done it is it will still just get the answer how it is. So I think that is good. Because when the cube goes, it returns a new position, which will be based on which face it ends up. So like in here, we'll basically have a position, we'll look which cube face we're on at the moment, which side we're going off, work out which orientation it is, work out which side of the new face we're going to be on at which index, and then we'll set the new position to be that, if it's not a wall, because it might be a wall. And I'm wondering if we can do some of the checks here. Yeah, so the wrap. Oh yeah, so the wrap can. Yeah, we don't have to worry about walls in the wrap. We just need a wrap, and then the wall check is done in the next. So it will see whether it can wrap. Well, it will wrap, and then it will say this is how we're wrapping, and if we're hitting a wall, we'll be like, nah, we can't go there, and it shouldn't change the direction. So yeah, I think that's good. So I think that is it for this video, I guess. A lot of things, and I might look up this thing and file a bug on that and work out how to get a better workaround, but